Before we go through and show how to simplify radicals, we're going to go through and show how to rewrite an example of a number that's being taken the square root of in a different way. We know that the square root of 16 is 4, but let's rewrite this in a different way. Couldn't we write 16 as the square root of 4 times the square root of 4? And we know from our rules that we can break down a number under a square root times another number under square root. So they each have their own square roots. This is a lot easier to complete because we know the square root of 4 is 2 and the square root of 4 is 2. So our result is going to be 2 times 2, which is 4, which goes back to our answer of what's the square root of 16? It's 4. I'm going to show another way that we can also break down the square root of 16. Let's say we want to rewrite 4 times 4 in terms of squared numbers. Couldn't I write 4 times 4 as 4 squared? And since square root and squared are opposite operations, they cancel out, and we would just be left with 4, which again we know is the answer to taking the square root of 16. Now let's show even another way to break down our square root of 16. We could create a factor tree and break down our 16 into all prime numbers. So let's pick a couple different numbers. Let's try 2 times 8. We know those multiply to 16. And let's keep going. Let's break down 8 into 2 times 4. And let's break down 4 into 2 times 2. When you're making your factor tree, you want to make sure that you're breaking everything down into prime numbers. Then you're going to see with your lowest numbers or your prime numbers if there are any pairs. Here we have a pair of 2's. We have another pair of 2's over here. We're not looking at 8 and 4 anymore because those are not our prime numbers, and we already broke down those numbers into smallest parts, which consist of the 2 times 2 times 2 times 2. If I multiplied all those 2's together, I would get my 16 results. Therefore, for each pair, you're going to write one of the numbers out front. So for that pair of 2's, I have a 2 out front. For this pair of 2's, I have a 2 out front. If there's anything left, it would go under the square root sign, but in this case, there isn't, so we don't need the square root sign. We can go ahead and multiply 2 times 2 to give us that 4, which again goes back to what is the square root of 16? 4. I'm showing you how to break down these square roots with a simpler number, a perfect square number, because it's easier to model. We're now going to work with some numbers that are not perfect squares, where we have to go through one of these ways to figure out how to break down or simplify the radical. Let's try example 1, the square root of 20. Let's try breaking down 20 into different numbers. So let's try multiplying 4 times the square root of 5. Now we know that they both originally were under the same square root, right? The square root of 4 times the square root of 5, right? But we can separate them and give them each their own square root according to our rules. So now looking at this, we know the square root of 4 is just a simple number 2. And the square root of 5 can't be broken down anymore. It's a prime number, so that's just going to be left as the square root of 5. Approaching this square root of 20 from the example of finding those perfect square numbers, we could do the exact same thing. We have square root of 4 times 5, and we can break that down into, well, 4 is 2 times 2, so we could write this as the square root of 2 times 5, and then rewrite this 2 times 2 as 2 squared. So we have the square root, 2 squared, times square root of 5. Easily here, we know squared and square root cancel, so we're left with a 2 out front, square root of 5. Completing this problem using factor tree, we can break up 20, and let's try a couple different numbers. Let's try into 2 and 10, and then we can break up 20 into 2 and 5. So looking at all of our lowest numbers, we can see we have a pair of 2's there, and we have a 5 really by itself. We can only bring out one of the pairs of numbers to the front because we're essentially saying 2 squared, and we want the square root of that. So that would just be 2. And then we place whatever's left over on the inside of 5. So again, we have 2 square root of 5. Now let's try the example square root of 50. Let's break down this square root of 50 into 5 and 10. And then let's try to break down this even more into 5 times 5 times, 2. There we go. Times 2. Well, looking at this, we have a pair of 5s, right? Following kind of the second explanation in our previous problem, we could rewrite that as 5 squared. And we still have this square root of 2. And we know that squared and square root cancel out, so we're left with 5 square root of 2. Trying it from another approach, instead of breaking it down into 5 and 10, let's try breaking it down into 2 and 25. Oh, okay, so now we have the square root of 2 times the square root of 25. And we know the square root of 25 is 5. And we just left with the square root of 2. Now I put the 5 in front because it's easier to read when we're multiplying. It might get a little confusing if I put the 5 behind. We might think it's under the square root sign. Approaching this from the factor tree aspect, we could break down 50 into, 2 and 25. Let's try that way. And then 25 can be broken down into 5 and 5. All our numbers are in lowest terms, or prime numbers. So when we pair them up, we have 2 pairs of 5s. So we know we can bring a 5 out to the front. And then we have a 2 that's by itself, so that stays under a radical sign. Let's try our last example of the square root of 80. This one's going to be a little bit harder because there are not really any perfect square numbers that we can initially find within here. Let's start breaking down 80 piece by piece. So we know 80 is really 2 times 40. We could break down 40 into 4 times 10. Oh, now we have the square root of 2 times the square root of 4 times the square root of 10. Now it's easy to figure out what the square root of 4 is. That's just a number 2 on the outside. And we still have this square root of 2, and whoops, I should probably still break down the square root of 10. That could be 2 times 5. Hey, look at that. Can't I rewrite the 2 times 2 underneath our square root as 4? So it's really the square root of 4 times the square root of 5 with a 2 on the outside. So this changes to 2 times 2 on the outside, right? We're bringing that 2 to the outside, times the square root of 5. So really we're going to get 4 square root of 5. Let's try it from the factor tree approach. So let's try breaking it down a different way. 8 and 10. We can break down 8 and 10 into 2 and 4. And 10 can be broken down into 2 and 5. This 4 can still be broken down into 2 and 2. So let's pair some things up. We have a pair of 2's here, so we can bring a 2 out to the front of the radical sign. We also have another pair of 2's right there. So we can bring that out to the front of the radical sign. And then we have this 5. Doesn't have a pair, so it stays inside. We can multiply the two 2's out front and get 4 to the 5th. Just like the results of our other example in front of us. Now that we're noticing some patterns, let's actually use our perfect square numbers to break this down. Using a calculator, maybe you can figure out other combinations of numbers that multiply to 80, but we can also have 16 times 5. Hey, look at that. Square root of 16 times the square root of 5. That's a little bit easier. Square root of 16 is 4 times the square root of 5, ending up getting the same result as our other two.